So today we're going to talk about how to sketch the graph of a polynomial, and the most important thing with sketching is the end behavior. And so I've already written these notes down, so pause this at any time if I'm going through too fast. So the end behavior of a polynomial is based on two things, and then the end behavior is basically how the graph behaves at the left and the right side of the graph. So over here, I'm going to explain this chart in 1 second, but these are all the possible ways a graph can end. It can point up at the left and the right, down at the left and the right, down at the beginning, up at the end, up at the beginning, down at the end. And I'm going to try to show you how to distinguish each of those with my examples. Okay, so the two things that you're going to base that on are called the leading coefficient and the degree. So the leading coefficient, and I'm just going to call that LC in a lot of these problems just to abbreviate, but it's the coefficient, so the number in front of the term with the highest power of x. And I've got a little polynomial just written underneath here to do this as an example. Okay, and then the degree of the polynomial is just the highest power of x. So let me write it down for these, or this polynomial right here. So I've got 5x cubed plus 4x squared plus 6x minus 7. Literally, the only thing it's based on is this very first term with the highest power of x. Now, the two options you can have here in terms of what you're going to look for. So we have two things in these. You have positive and negative, and then you have even or odd. So the positive negative goes with the leading coefficient, and then the degree goes with the even or odd. So in this case, my leading coefficient is going to be the 5 out in front of that x to the third, and so obviously that's a positive number. And then my degree here is the highest power of x. That's going to be 3. So that would be odd. So I'm going to come over here real quick. Positive and odd would mean if we were to put this on the graph, which we'll show you how to do in a second, the beginning of the graph would point down and the end of the graph would point up. Let me go through, I know I didn't leave space here, but let me go through just like a basic example of each of these four. Okay, so, and actually let me start with the odd functions. So the most basic odd function would be a line. So just y equals x. Okay, so my leading coefficient there, this would just be 1. So that's going to be positive. And my degree here would also be 1. I just have like a little x to the first. So I just want you guys to kind of think about the graph of y equals x. So just as a sketch, I don't have any y-intercept or anything like that, so just start at 0, 0. Our slope would be 1, so we'd go up 1 over 1, up 1 over 1, little sketch. And you guys can see this is going down at the beginning and up at the end. And that's going to follow that behavior there. Now, your most basic odd function with the negative would be y equals negative x. It's just a line. And again, your leading coefficient here is negative 1, because I got a negative in front of that. The degree is still 1. So, whoops, I should have written odd on that. This is negative and odd. And just as a little sketch, just to think about this, again, no y-intercept, I just start at 0. But for here, I go down 1 over 1. So it flips over the direction of the graph. And you guys can see then, this goes up at the beginning and down at the end. I always remember odd functions. Whoops, sorry about that. I always remember odd functions. The ends go opposite directions. I don't know if that'll help, but if you want to write that down, odd functions, the end behavior always goes opposite directions. And again, I just like to think of these most basic functions to kind of think about what the end, what the end behavior would look like. Okay, now, your most basic even function. I just got a piece of paper here. Okay, y equals x squared. This is just a parabola. My leading coefficient here is 1, which is positive, and my degree here, this is 2, which is even. So if you guys think about the parabola graph, vertex is 0, 0, and then that squared causes the sides of the graph to go the same direction. So the end behavior here is up and up. If you do most basic even function with a negative, would just be negative x squared. Leading coefficient there would be -1, which is obviously negative, and the degree is 2, which is even, and so negative even, we'll just sketch a little graph here. This graph, and we're not plotting specific points, I'm just giving you guys a sketch, but that negative turns that graph upside down, and you guys can see the end behavior here, both ends go down. So if you have an even function, which I do here, this like x squared, x to the 4th, x to the 6th, those end behaviors are going to point the same direction, either both up or both down. So I'm going to switch back to the note paper here, and now my first example is situations where we have polynomials in standard form, and I've got this little end behavior chart here to help me. I know you won't be able to see it on the screen, but how do I figure out the leading coefficient if I'm in factored form? Because this little example I gave you and the examples I was just drawing, those were not in factored form. Now, the reason I got these in factored form is because it's easy to see where the graph would cross the x-axis, the zeros. We were talking about that in our last lesson. So we need those for the graph. But to do the end behavior, here's what I want you to look at. You want to find, I'm not asking you to multiply this out. I just need the highest power of x. And so that would result in multiplying the first term in each of those factors there. So if I sat here and multiplied this out, again, I'm not asking you to do that, but I would have x times x times x. So I would have x to the 3rd. There's no number in front of any of those x's, and so that's just going to be our leading coefficient. Now, this is just leading coefficient would be 1, so this is positive, and your degree is 3, so this is odd. So I automatically know the end behavior here. This is like a line with a positive slope, so I'm going to go down at the beginning and up at the end. Now, here's what you want to do additionally that we haven't talked about yet. I need to find the places where the graph should cross the x-axis, and that's just your zeros. So whatever would make these little parentheses 0, so I'm going to cross at 6, I'm going to cross at 1, and I'm going to cross at -2. Those are the values, if we plug those in for x, would make the equation equal to 0. So I'm just going to draw a little dot on each one of those. And this is just going to be a sketch. Now, I always start with the end behavior. So I know this is positive and odd, so it should go down at the beginning and up at the end. So down on the far left and up at the far right. And then we don't have any multiplicities here. We're going to talk about that on the back. But if we just have plain zeros here, you're just going to go through the x-axis. And this is just a sketch. Now, I know I have to come back down because I have to go through 1. And then you just go ahead and go through the x-axis. And then you know you have to come back up because you have to go through the 6. Just a sketch, but the graph would look something like this. I'm looking for the correct end behavior, and does the graph go through the correct points? Okay, so if we multiplied this guy out, I've got -x, x, and x. So this would be -x to the 3rd. So I'm trying to give you guys one of each of these examples. So this is going to be negative because of the -1, and odd because of the degree, which is 3. Now, remember, if you have an x out in front, if I would plug in 0 there, that would make the whole thing 0. This is going to be +5 and -3. So those are the 3 places we're going to go through the x-axis. So just find those. Here's -3, here's 0, here's 5. Okay, negative and odd means I'm going to go up at the beginning and down at the end. So I start out with the end behavior, the 0 to the far left and the 0 to the far right. And then no multiplicities or anything. We'll talk about that on the back. So you just go right through the x-axis, but you know you have to come back up and go through the x-axis, and then you know you have to come back down. So something like that. All right, now I've got 1, 2, 3, 4. So if I multiplied that all out, we would end up with x to the 4th. So this is going to be just a coefficient of 1, so that's going to be positive. And now my exponent is even. And my end behavior for positive and even is just like a parabola, like y equals x squared. So both ends are going to point the same direction, which is going to be up in this situation. So I got to identify my zeros. So I'm going to have 0, 3, -2, and 6. So usually just come right down to the graph. So here's -2, here's 0, here's 3, here's 6. Okay, I'm going to draw in my end behavior. Both of these are going to go up. Okay, now we're just going to, no multiplicities, we're just going to wave right through the x-axis. So I'm going to go through the x-axis, but I know I have to come back up to go through 0. Go through the x-axis, but you know you have to come back down to go through the 3. Go through the x-axis, but you know you have to come back up to go through the 6. It should look something like that. Again, these are just sketches. I'm looking for, do you have the correct end behavior, and do you go through the correct zeros? All right, now this last one has one factor that looks a little different than what we've been doing. But if I multiply this out, I have -x, I have 2x, I have x, and I have x. If I multiplied those all out, I've got 1, 2, 3, 4 x's, so it's going to be x to the 4th. But here I have a negative and I have a 2. So this would be my leading coefficient if we multiplied that out, -2x to the 4th. Okay, so -2 is obviously negative, and my degree is 4, so this is going to be even. Now, a negative leading coefficient for an even function is going to cause the graph for both end behaviors to go down. Now, let's go through and do the zeros. This is just 0. Let me skip this one for a second. This is going to be 4. This is going to be -1. Now, remember, it's whatever would set the parentheses equal to 0. So I'm just going to come over here real quick. If I had 2x plus 5 and that was equal to 0, if I solved that, I would subtract 5 and I would divide by 2. So if you do -5 divided by 2, you're going to get -5 over 2, or if you prefer a decimal, -2.5. So that's going to be my other zero. So if you get something like that, just estimate where it would be. It doesn't have to be perfect. So -2.5, I'm going to just come right between the -2 and the 3. I'm also supposed to go through -1, I'm supposed to go through 0, and then I'm supposed to go through 4. Okay, end behavior here is down and down. So just the far left, far right. And then we're just going to wave through. Go through your x-axis, come back down to go through the -1, come back up to go through the 0, and then come back down to go through the 4. So sketch of the graph, something like that. Okay, now I mentioned multiplicities on the front, so I want to talk to you about that on the back. So multiplicity, so here's what I'm going to write down. An even multiplicity creates what we call a bounce. And when we get to some of these examples, I think that's going to make a little bit more sense on the graph. But what happens if you have an even multiplicity? Creating what I call a bounce. It doesn't go through your x-axis. Okay, so for example, let's say, I'm just going to do a little basic function. Let's say we have y equals, and then we have x minus 2 squared. Okay, this is going to go through 2. But if you guys think about this, this is just the equation of a parabola real quick. So here, this would be like vertex form. I know we haven't talked about that in a while, but this is going to go through 2, and that would just be the vertex of the parabola. This even multiplicity is going to cause where I touch the x-axis doesn't actually go through the x-axis, it bounces back up, because when you square something it makes everything positive, and so in that case that's going to cause what I call a bounce. So you notice when I did the 0, I did not go through the x-axis. This only happens if you have an even multiplicity. If you have an odd multiplicity, all the questions on the front had that. They didn't have any powers, so it'd just be to the first. So odd multiplicity goes through. So if you have a third power or fifth power or something like that, that's going to go through. And so we're going to get into some examples that have some multiplicities here. Okay, now here's another thing that you might run into. We're not in factored form, so it's not easy to see the zeros. The leading coefficient here and the degree, though, are really easy to see. So this is x to the fifth. So this is going to be positive and odd. So I know my end behavior down at the beginning, up at the end right away. And what we have to do here, if it's not in factored form, is factor it like we were doing in a previous lesson, so we can see the zeros. So look for your highest power of x here. I've got 1, 2, 3 terms, and each of them have at least x to the third. So I'm going to take that out in front. Left over, I would have x squared minus 6x plus 9. And then we want to further factor, just in the parentheses, multiply to get 9, add to get negative 6. This is going to be x minus 3 times x minus 3, or x minus 3 squared. Okay, now this is going to go through 0. There's no multiplicity bounce there because that exponent is 3. That's odd, that goes through. I'm going to go through 3, and this is going to have a bounce because you have a squared on it. So even anytime your multiplicity, it's just that exponent. If your multiplicity is even, you're going to have a bounce. So we're going to go through 0, and we're going to go through 3. So I'm going to plot those. Now, if you did the end behavior correctly, this should work just fine. Now, what I normally do if I have a bounce, so I know I have a bounce on the 3, I'll just circle that on the graph for myself so I remind myself don't go through that point when I actually put this on the graph. So my end behavior, down at the beginning, up at the end. Now, for an odd multiplicity, go through the x-axis. And then I know I have to come back down because I go through the 3, and it kind of creates like right there like a little bit of a parabola shape, and then it bounces back up. Alright, this one, your leading coefficient is negative x to the fourth, so this is negative and this is even. So I know that my even goes the same direction, negative they both go down. So we're just going to go ahead and factor this here real quick. Now, I'm going to factor out a negative here. So I have at least x squared, but I'm going to factor out negative x squared when I do that. Now, that'll change that first term to x squared, and this will become negative 16. So the reason I'm doing that is because what's left over in the parentheses will be easier to factor. So to factor out a negative if your leading coefficient is negative and you're trying to factor. Alright, so this is negative x squared. Now, this is a difference of squares, so this is x minus 4, x plus 4, multiply to get negative 16, add to get 0. Okay, this is just a 0. This is going to have a multiplicity of 2, though, so I'm not going to go through the x-axis, we're going to bounce. Now, this is just a plain 4 and a plain negative 4. Don't have any multiplicities, so I'm going to go through the x-axis on those two. So, here's negative 4, here's 0, here's 4, and then again, it's totally up to you, but I just remind myself, like, okay, here's a multiplicity, I'm not actually going to go through the x-axis. Alright, so I know I need to go down at the beginning and down at the end. Odd multiplicities, go ahead, go through the x-axis, but you know you have to come back down to go through 0. And then bounce, don't go through the x-axis, just go back up. And then you got to come back down because you have to go through the 4. So just a sketch, the graph would look something like that. And then just a little bit more practice with multiplicities. So if you guys think about this just for a second, and I'm not asking you to multiply this out, but this is squared, and this x plus 4 is to the third. So I just want you to think about this. You don't have to write it out. But if we multiplied that whole thing out, what would your highest power of x be here? you have 2 of these and 3 of these. So all written out, I'd have 1, 2, 3, 4, 5 x to the 5th. Nothing causing that to be negative. So this is positive, and this is to the 5th, so it's odd, down at the beginning and up at the end. Okay, now we're going to go through 1. That's going to have a multiplicity of 2, so that's going to create a bounce, and then negative 4. But this exponent is odd. If it's odd, it does not have a bounce. We're going to go right through. So here at negative 4 and here at 1, and I'm just going to circle the 1 because I know I have a bounce. Okay, so down at the beginning, up at the end. We have an odd multiplicity, so I go through the x-axis, but I know I have to come back down because I have to go through that 1. And then that bounces back up, and my graph is already completed. And I just have one more here. If you were to multiply this out, x squared times x would give you x to the 4th. So this is going to be positive and even. It's going to go up at the beginning and up at the end. We're going to go through 0 with a multiplicity of 2. We're going to go through 4, and we're going to go through negative 3. So here's negative 3, here's 0, here's 4. Little reminder, so I bounce. My end behavior is going to be up and up. Up at the beginning and up at the end. Okay, odd multiplicities, go ahead, go through the x-axis, but you know you have to come back up to go through 0. Bounce back down, and then you have to come back up to go through the 4. Okay, and to find the degree of a polynomial from the graph, just going to talk about that real quick. So these are already graphed for you, and forgive me, these should have arrows on the end for the end behavior. So just to figure out the lowest possible degree, here's what you want to remember, is the number of times the graph switches direction. Number of times the graph switches direction. So I like to grab 2 highlighters, or you could just do this with a pencil, but I want to show this to you. Okay, so basically it's a switch between increasing and decreasing. So here, graph is increasing, and then I switch direction. Then I am decreasing, and then I switch back to increasing. So how many different times here? I've got 1, 2, 3, so the lowest power here, lowest degree here is 3rd power. Alright, so I'm going to do the same thing here. Here I'm increasing, then I'm decreasing, we'll bounce here, increasing, hold it, and then decreasing. So I got 4 different colors on that, so this has to be a 4th degree. That makes sense. I've got an end behavior that's even. This one has an end behavior that's odd with opposites. Even goes the same. And then I just have one more. So this graph decreasing. Then we're increasing. So just the number of times I switch directions. So then here I'm decreasing. Here I'm increasing. And so you can see again, this one's 4 different directions pointed a different way, so the minimum degree here, this is also a 4th degree. Okay, now on this last page, this is kind of a summary, and I'm going to add a little thing in here. See if you can write the factored form of the polynomial, the lowest possible factored form. So from just looking at the graph, my end behavior here, this is going up and up. So I know the leading coefficient has to be positive. And in terms of the lowest possible degree, remember we were talking about the number of times I switch direction from increasing to decreasing. So I've got 1, 2, 3, 4. So this is going to be a 4th degree. Zeros are where you're crossing the x-axis. You're crossing at -4, -1, 3, and 6. Okay, there's no bouncing there. And so what I'm going to have us do in this last little part of the question is write the factored form. So if your 0 is -4, x plus 4 would be the factor. If your 0 is -1, x plus 1 would be the factor. 3 would be a factor of x minus 3, and 6 would be a factor of x minus 6, and that's all you have to do. Okay, the end behavior here, both of these point down, so I know the leading coefficient has to be negative, and this is going to be even since they both point the same way, but let me count the different times it switches direction for a degree. So I've got 1, 2, 3, 4, so this is going to be 4th degree. Zeros here, it looks like we're going through negative 3. Now, here I go through 1, and then here I go through 5. Now, let me make a note here. So, this is a bounce. So, I need an even multiplicity on this. So you can honestly, because we don't really know, we don't have the equation of the graph, and we don't even have any y coordinates because we just have kind of a blank y-axis. So I need to put an even multiplicity, but that's 0. You can use 2, you can use 4, you can use 6. I usually just use the lowest possible, which would be a 2. So factored form here, the 1 has a bounce, so none of the others do. So this is just a plain x plus 3. The 1 has a bounce, so I'm going to say x minus 1, and I have to square that, or 4th power, or 6th power. It's got to be even. Like I said, usually for me I just use a 2. And then you've got a 5, so x minus 5 would be the factor. So if you see a bounce, make sure you got an even multiplicity on that factor, even exponent. And I just have 2 more here real quick. Got one of each of our types of end behavior here. So this is down at the beginning and up at the end. And let me just show you a little thing. Remember I showed you guys the parabolas and I showed you the lines. If I'm not sure and I've got an odd function, here's what I do. I just kind of sketch in a line to mimic the end behavior. So I just sketched in a line. This is going down at the beginning, up at the end, and I think about, okay, would that line I just drew have a positive or negative slope? So this would be going up and over to the right, so this would have a positive slope, and so I know this odd function is positive, so that's how I remember that. Okay, so that the little line, just a little sketch to help me think about that. Now, in terms of your degree, you're going you got 1, 2, 3 different directions, so this is a 3rd degree. Zeros, try and kind of ignore that line. You're going through negative 5, you're going through 0, and you're going through 2. You don't have any bounces, so we don't have any multiplicities to worry about. Now what I'm going to do here, for 0, you would just write an x, and so I'm just going to write that out in front. For the negative 5, it would be x plus 5, and for the 2, it would be x minus 2. Okay, and then last one, actually, let me choose a little bit lighter color here, but again, here I'm just going to sketch a line that mimics the end behavior, and I'm going to think about what would the slope of that line be. So this is going down and over, so this would have a negative slope. So that end behavior where you're up at the beginning and down at the end, that's going to be a negative leading coefficient. Now the degree here, okay, we're going down 1, up 2, down 3, up 4, down 5. So this is a 5th degree. This one's really complicated. Okay, now let me look back at the graph. So my zeros, I'm going through negative 4. I am not going through, but I am touching negative 1. So that has an even multiplicity because I've got a bounce here. All right, I go through positive 4 and I go through 6. So the only multiplicity I have to worry about is on where I go touch the negative 1. So I'm going to write x plus 4. I bounce at the negative 1. So I'm going to write x plus 1, and we have to give it an even multiplicity. Again, it could be squared, it could be the 4th, whatever even number you want. I just use a 2. And then the other factors, 4 would be x minus 4 as your linear factor if 4 is your 0, and 6 is a 0, so my linear factor would be x minus 6, and that's my factored form.